Continuing with more videos based on circle MCQ. In this question, it says that AD is the diameter of a circle. So as you know, AD is the diameter. The moment you see AD as a diameter, first you write down the angle subtended by this diameter on the circle is 90-degree. Reason is angle in a semicircle is right angle. Further, we have AD is equal to the length of AD is equal to DE. Now, when two sides are equal, the angles opposite to these two sides will also be equals. So x plus the one which is given as 90-degree here is equal to 180 degrees. So we can say 2x is equal to 180 minus 90, that is 19. So x is equal to 45 degrees. So I can say that we even know the values of this angle as 45 degrees. So I should write this angle, this being 45 degree. This is also 45 degree. This we already calculated as 90. But we can see that the measure of an angle is given here. And this angle is given as, this is 115 degree. And what do we have to find out is the measure of angle CAE. That means we have to get the measurement of this whole angle. Well, as of now, we already know the value of this angle, right? And then we have to find the remaining part of it so as to get this CAE. This is what the red portion is what we have to calculate. Now look into the angles that we already know. This angle is 115. So we can see this ABCD is a cyclic quadrilateral. This is ABCD is a cyclic quadrilateral. We mark this. Right. You can see ABCD is a cyclic quadrilateral as its four vertices are on the circle. So we can say that one of its angle is given. So we can find this angle, right? So opposite angles of cyclic quadrilateral are supplementary. So we can say that the value of angle CDA will be 180 minus 115. So that will give you 65 degree. And this is the reason here is that opposite angles of cyclic quadrilateral are supplementary. Now we got this value as 65. Now what I'm going to do is to apply angle sum property. So we'll apply angle sum property in this triangle. Let's say in this triangle, we know the value of two angles. One is 90 and the other is 65. So we can get the third angle, and the third angle can be calculated using this property. That is angle sum property. So I can say over here that is 65 plus, say this angle which is missing, I'm naming it Y, and plus 90 should give you 180 degree. So we can say Y is equal to 180 minus sum of these two, that is 155 degree. So that Y will come as, you see, this is 90 plus 65, that is 155. So now I will subtract 155 from 180. So that's giving us 25 degree. So the one which they were asked to find out is 25 degree. This angle we got as 25 degree. Let me write on this. This is 25 degree. Now, let's say we have to get CAE. So the CA is this whole angle. That is 25 plus 45. So that comes out to be 25 plus 45. That gives you 70. So C is the correct answer for this. In the next question, there is a figure given, as you can see, where we know the measurement of two angles, that is angle ABC as 50 and angle BDC as 40 degree. Now we have to find angle BCA. Now what you can see, that is BCA is this angle. BCA is this angle. And you should know that this angle can be calculated if we know the value of this angle as it is forming a cyclic quadrilateral. So what you'll do here, we can see that this angle, this is 50 degrees subtended by arc AC, and the same arc is subtending this angle, that is angle ADC. So angle on the same segment are equal. So we say this angle, that is ADB, is this angle, that is angle ADB, as 40 plus 50, that is 90 degree. So what we can say that this angle will also be 90 degree. As you know that opposite angles of cyclic quadrilateral are supplementary. This is 180 degree. As we know the value of this angle as 40 plus 50, that is 90 degree. So 90 degree plus angle ACB is equal to 180 degree. So clearly angle ACB will be 180 minus 90. That is equal to 90 degrees. So we have this option as the correct answer. In the next question, we are given a figure as you can see, and in this figure, we know the value of two angles. This is angle OAB. Angle OAB is mentioned. So this angle is given as 40 degree and this is 30 degree. And we have to get the measurement of this angle AOC. Now, what you can see that this angle is subtended by this arc AC, minor arc AC, and the same minor arc is subtending an angle on the circle. So if you know the measurement of this angle, I can say the value of this angle. So for that, we need a construction where we'll be joining O with B. Now, what you can see here that here these two sides are equal. So we can apply the property that angles opposite to equal sides are equal. So since this angle is 40, right? Since this angle A is 40, therefore angle OBA should also be 40. Now coming to the other triangle, that means I'm talking about this triangle BOC. Look into this triangle BOC. In this triangle, what you can see that here also two sides are equal. That is OB and OC being the radii. So need to see that OB and this is OB and OC are the radii. So we can say here these in this triangle also two sides are equal. So therefore this angle will also be 30 degree. Now we can say that angle ABC is equal to 30 plus 40. So that is equal to 70 degree. So now we'll find angle AOC. The property is that the angle subtended by an arc at the center is twice the angle subtended by the arc on the remaining part of the circle. So we can say angle AOC is equal to twice of 70, that is equal to 140 degree. In this next question, we are given the value of an angle. This is given as 40 degree, and we have to find the measurement of angle ACB. We have to get the value of this angle, that is ACB. But you can see that here O is the center, and we can say therefore this is the diameter, right? This is diameter. So we can find the value of this angle. As you know, angle in a semicircle is right angle. So this will be 90 degree. Now, if we apply angle sum property in triangle ABC, we know the value of two angles. So by property, the third angle will be 50 degree. And if it is not mentioned, it is a diameter, we have another alternate way that in this triangle, OA is equal to OB. So this will also be 40 degree. And then we can say that by exterior angle property, this will be 80 degree, right? As you know that the exterior angle of a triangle is equal to sum of two interior opposite angle. But then if this line is produced, right, therefore this has to be done by the same way. Well, this will be 50 in other case also. As you can see that this angle is 80 degree and the other two angles will be equal because these two sides are equal and the angles opposite to equal sides are equal. So even if it is not mentioned, but it has to mention that here AC is basically a chord passing through the center. So we can use the property of angle in a semicircle. In the next, we have a figure where BC is given the diameter of the circle, and further we know the value of angle BAO. This angle is given as 60 degree. So we know the value of this angle as 60 degree. And then we have to find the measure of angle ADC. Well, clearly this ADC is made by the arc AC here, right? And the arc AC is subtending an angle at the center, this one. So the same arc is subtending an angle on the remaining part of the circle, that is this one. So in case if we know the value of this, we can determine the value of this angle. So we need to find the measure of this angle. For that, what we can do, we can see that in this triangle, OA and OB are the radii, right? Let me shed the triangle for proper understanding. So I mean to say about this triangle. You can see this is an isosceles triangle. The reason for this will be, you see, OA is equal to OB as they are radii. So the angles opposite to these two sides must be equal. So I can see that this is the side opposite to OB and sorry, this is the angle opposite to OB and this is the angle opposite to AO. So this will also be 60 degree. Now check here the angles which we are seeking for. That means this angle whose value AOC is an exterior angle and the exterior angle of a triangle is equal to sum of two interior opposite angle. Now, as I said that these two angles are made by the same arc, one at the center, other on the remaining part of the circle. So using alternate segment, as you know that the angle subtended by an arc at the center is twice the angle subtended by it on the remaining part of the circle. So therefore, this angle will be half of 120, that is 60 degree. So our correct answer will be this, that is 60 degree. Continuing with the next question, we have the measurements of two angles given here. This one is given as 50 degree. As for the figure, you can see this angle is given as 50 degree and the other angle is 70 degree, that is CBA. So these two angles are given for the same triangle. So let me shed the triangle, the one whose two angles are known. So we actually know the values of two angles of this triangle, that is ABC. Right. So by angle sum property, we can determine the value of the third angle, that is this one. By angle sum property, it should come as 60, as you know that the sum of three angles of a triangle is 180 degree. So if two of them is 50 and 70, their sum is 120. So this is 60. Now we have to find the value of angle ADB, that is this angle ADB. So angle ADB, you see here, angle AD B should be equal to angle ACB. That's from the angles on the same segment. As you can see, these two angles are made by the same arc on the same side. So this will also be equal to 60 degree. We should write this as 60 degree. This is one very easy question based on alternate segment. We have the value of angle ACB and that is given as 45 degree. Clearly, we can see that this angle ABC is obtained by this minor arc AC. The same minor arc is also subtending an angle on this at center, right? Right. So we know that the angle subtended by an arc at the center is twice the angle subtended by it on the remaining part of the circle. So we can say the value of angle AOC will be twice of this angle, that is angle ABC. So it is twice of 45 degree. So it comes out to be 90 degree. In the next question, we are given the value of this angle, that is angle APC as 120, APB, right? This is APB as 120 degree, and this angle, that is, this is angle DBC. This angle is given as 25 degree. As you can see, we have to find the value of angle AD, this angle, right? That is angle ADB, right? So we have to find the measurement of angle ADB. What we can use here, we have two properties by which we can do. So let's do by one way. I can see that this angle DAC and DBC are made by the same segment. Now you have to see that the segment I'm talking about, they are actually subtended by this arc, right? So angle in the same segment, by using the property of angle on the same segment, I can see the value of angle DAC will be same as angle DBC, and that should be 25 degree each. Now, if you know the value of this angle as 25 degree and consider this angle to be x, so I can see that we can apply exterior angle property. Need to see that here in this triangle, the one which I'm shading with yellow, this angle that is 120 degree is an exterior angle. And what do we know? That exterior angle of a triangle is equal to sum of its two interior opposite angle. So I can say x plus 25 is equal to 120. So x is equal to 120 minus 25. So x should give you 95 degree. So this should be our answer. Here in this question, it says O is the center, and that means BD will be the diameter. We know the measurement of one angle, that is, this is angle ABD is given as 30 degree, 35 degree, and we have to find the measurement of angle ACB. This is what we have required to find out. As you know that angle in a semicircle is right angle, so we can say this angle is 90 degree. We should say this angle as 90 degree. That is, angle in a semicircle is right angle. So in this triangle, we can see that we know the value of two angles. Here in this triangle, I'm talking about this triangle. We know actually the measurement of two angles. One is 90, another is 35. So by angle sum property, we can get the measurement of the third angle. And the third angle is this, right? So it should come as 55 degree. This is 90 and yeah, 55 degree. Now check for the next part. In order to get this angle, the required one, we can see that these two are actually subtended by the same arc AC. You can see AB, sorry. AB is subtending this angle and AB is also subtending this angle. So angle on the same segment are equal. So we can say that the measurement of angle ACB will be same as angle ADB, and that is equal to 55 degrees. So we got this as 55 degree. Here in this figure, we are given the value of angle CDB. This is mentioned as 40 degree. Yeah, this angle we know as 40 degree. But you can observe that this angle is subtended by this arc BC, and the same arc BC is also subtending an angle on the same segment. So clearly by using this property that angle on the same segment are equal, I can write the value of this angle as 40 degree. So this is also 40 degree. Now what we have to find out is the value of angle PAC. Yeah, this is angle PAC. Clearly, it's forming a linear pair. So PAC plus 40 is equal to 180 degree. So angle PAC will be 180 minus 40, that is 140 degrees. So this is the correct answer. As we can see, we are given in this question two circles, and these two circles intersect at 2 points, that is P and Q. We know the measurement of angle ABC. This is given as 75 degree. So we know the measurement of this angle, that is 75 degree, I can see. Now we have to find the measurement of angle PAD, right? That is PAD is this angle. This is what we have to get. Now, this is based on the property that opposite angles of cyclic quadrilateral are supplementary. So I can say that the value of this will be, as you know, that 75 plus this angle is equal to 180 degree. Opposite angles of cyclic quadrilateral are supplementary. So angle PQC will be 180 minus 75, that is equal to 105. This angle will be equal to PQC is 105. Now further we can apply linear pair, and applying linear pair we can say the value of this angle will be, that is 180 minus, right, PQD is 180 minus 105, that is 75. Now we have to consider the other cyclic quadrilateral. We are talking about AP, like let me just borderline the quadrilateral I'm talking about. So here I'm talking about this quadrilateral. Yeah. This is also a cyclic quadrilateral. So here the opposite angles are supplementary. So we can again use the same property and say opposite angles of cyclic quadrilateral are supplementary. So using this, I can say the value of angle ADP will be equal to 180 minus 75, that is equal to 105. So let me explain this part again. We have this angle given as 75 and these two angles are supplementary. The opposite angles of cyclic quadrilateral are supplementary. So we got the value of angle PQC as 105. Further, applying linear pair, I can say the value of this angle, that is AQD, or say PQD, sorry, PQD as 75. Linear pair is sum of all angles around a point is 360 degree, 180 degree. So once we got the value of this angle, now again we applied cyclic quadrilateral property that opposite angles of cyclic quadrilateral are supplementary. So since we know the value of this angle as 75, we'll get this as 105.